Kia ora tato, I'm Madeline Newman, the Executive Director of the AI Forum for New Zealand. And you're probably aware of aerial drones and their captivating imagery, but what you may not know about are their submersible equivalent, an uncrewed underwater vehicle. This is the area of expertise for Boxfish Research, and theirs is a gem of a New Zealand tech story. The robotics manufacturer is making a big splash in the competitive global market. They're becoming known for best-in-class underwater vision tech that solves complex problems. Now, the company began in 2016 with its innovative Boxfish ROV, a remotely operated vehicle that delivers unmatched image quality and vehicle control. Forever pushing the boundaries, in 2021, Boxfish launched a groundbreaking drone for underwater cinematography. Used by blue-chip natural history productions, Boxfish Luna is changing the landscape of wildlife filmmaking. ROVs are game-changing when using divers is impossible or dangerous, but the cable which connects it with the surface has limitations, so Boxfish created an autonomous vehicle in collaboration with Norway's Transmark Subsea. The result is ARV-i, a unique tool for offshore inspections, able to carry out remote observations and stay submerged for months. I'm here with Ben King, one of the co-founders of Boxfish. Welcome, Ben.
Thanks for having me.
No problem at all. Hey, tell us a little bit more about autonomous underwater vehicles and specifically ARV-i. How do they work?
Yeah, okay. It's something that's a bit new to most people. So the easiest way to describe it would be to think of your robotic vacuum cleaner that you might have roaming around your house, or maybe the lawnmower. So essentially it's an underwater version of that. So it has a little dock, and it resides in that, where it charges and transfers data. And then when it's ready to head out and do some work, it leaves the dock, does the mission, whatever it may be, and returns to the dock to upload the data that it's captured. And the first sort of applications that we're working on are in the aquaculture industry, to identify issues in the fish farm, to actually calculate the size and weight of the fish, as well as identify health issues with them.
Is that kind of like facial recognition technology for fish?
Yeah, you could say that. That's certainly something that's possible. And there's a myriad of other applications in that industry and globally for any number of things. So yeah, it's pretty exciting.
And why is there a need for this kind of technology? So what sort of problems were you aiming to solve when you designed ARV-i?
Yeah, good question. So essentially, aquaculture is having to go further offshore in order to clean up the industry, but also to increase the amount of output that they can achieve in order to feed more and more people with it. So being able to do more hands-off reduces the risk to staff and equipment. So essentially, if there's an aquaculture installation that's well offshore, it's really useful to be able to monitor and do a lot of the activity without actually having to go there with a boat. And then beyond that, there's all sorts of other applications where regular inspections are required, say a buried cable that needs to be inspected regularly. Well, why send vehicles down from a mothership with a whole bunch of crew and other things, when you can actually do it autonomously and have the vehicle go out and do the work and then come back and upload that data without much intervention at all.
Would that be the same for sort of an offshore installation, like an oil rig or a building of some variety?
Yeah, it certainly has a lot of applications in any offshore industry. So anything that's currently done using ROVs or tethered vehicles, essentially, many of those applications, especially repetitive type tasks, can be done using autonomous vehicles instead.
So I mean, those are really good examples of how RVs are applied in the field. What sort of unique capabilities does this kind of autonomous tech solution offer the market?
I mean, our solution has a wide range of sensors and cameras that can be integrated, and a really good example that we're currently deploying in the fjords of Norway is using stereoscopic cameras to actually measure the physical size and then to infer the mass of individual fish in a fish farm. And this goes on further to, as I said, to identify potential health issues with the individual fish. And so that data is extremely important to the fish farmer, to understand when it's the best time to harvest the fish and ensure that they're in top quality.
Okay, as I mentioned in the introduction, one limitation of ROV technology is the tether connecting the vehicle to the surface. Are there similar challenges and constraints with AUVs and RV? You know, transmission of data and things like that.
It's completely different challenges. There are challenges, of course. The main one being, as you've identified, that it's very difficult to send much data through the water. So hence why the vehicle is autonomous and uses such things as AI and machine vision, etc., to actually avoid obstacles, to make its own path planning as it goes along based on what it actually encounters. It does have the capability to send small amounts of data back or two ways from the dock. But the main data transfer occurs wirelessly, but at very short range once it's back in the dock. On the contrary, a tethered vehicle uses fiber optic tethers and has almost an unlimited bandwidth to send as much data as you want up to the surface. So they're kind of two opposite ends of the spectrum.
So does that mean you're doing a lot of the calculations and the actual processing within the vehicle itself, so that you're
that's right.
Basically transmitting the findings rather than the whole data set.
Yeah, that's right. So the vehicle does a lot of the sort of classification of imagery, if that's what is the data of interest, or whatever else you want to do, can be done on board, so that the transfer of data either through the water, if that's required, some sort of go no go type information, or more detailed information that's uploaded once you get to the dock, and you can still minimize the size of that data payload once you get back into the dock.
Excellent. Hey, how big is it? Because I mean, I always think of submarines and things like that, but it's obviously not that big.
Yeah, good question. You could probably think of it as it's about 700 millimeters long and 400 millimeters wide, sort of thing. So think of it as the size of a lawnmower or something.
Okay.
And the dock is about 1 meter by 1 meter.
So fairly small then compared to your average submersible.
Yeah. It's portable by a single person, so they're about 20 to 25 kilograms.
And so I mean, the bit that I really want to get on with, that I'm really want to talk about, because I'm really interested in Boxfish Luna and your wildlife filmmaking experience. So you've been to some fascinating places. Do you want to just tell us a little bit about how Boxfish Luna works, and how groundbreaking that is?
Yeah, absolutely. So when we sort of first got into this about 7 or 8 years ago, one of the things that we sort of set out to do was to redefine what you could do under the water in terms of being able to capture, cinema quality footage with an underwater drone. And we saw it all happening in the aerial space and thought, hey, that would be pretty cool to do it underwater too. And so that's where the Luna comes in. Essentially, it has cameras in it that provide that sort of level of qualities, 8K, high bit rate footage that can be used directly for production type stuff. And yeah, that's been really successful, and we've so far been able to deploy the Boxfish in Antarctica ourselves a number of times, and our customers are regularly working in the most extreme parts of the world, from the Arctic to Antarctica. And we also did a project looking for Amelia Earhart's lost airplane in Papua New Guinea at one point. So that was pretty interesting, deploying the vehicle off a dugout canoe in 40+ degree heat. Yeah, it was really a great project as well.
Sounds pretty exciting, pretty adventurous. How is it? So this is kind of where you're sending Luna into places where it's not really convenient or not really possible to send an actual diver.
Yeah, absolutely. So that's really where it comes into its own for a number of reasons. I mean, the Boxfish is capable of movements that divers can't achieve, so that's one sort of area, but also the safety aspect. So no need for decompression chambers, safety divers, all of that stuff. But of course, we can go well beyond what a diver can do. Divers operate generally to about 40 meters. And we can operate down to 1,000 meters. So completely new areas that are, unreachable by divers. But also we have a bunch of sensors and additional equipment that can be integrated to assist as well, to hold position and do other things that really help the operator to get the shot that they're after.
Sounds absolutely amazing. Are there any productions you can let us know about that you've been involved in?
Well, generally our work is with science. So we worked with Dr. Regina Iser, who has a long-term project in the Antarctic studying whale behavior, and so we've worked with her for 2 seasons down in Antarctica, and we're able to fly the drones out to the ice edge by helicopter and then deploy under to observe killer whales doing their thing along the ice edge, which was really phenomenal.
Yeah, that is amazing. Hey, autonomous vehicles clearly offers enormous opportunities for development and industry innovation. What do you see as the future for these kinds of underwater vehicles?
Yeah, there's a really bright future for this. I mean, you name it, it can be done, using automation and adding value to, offshore wind is a really interesting key market where a lot of it depends on continuous monitoring. And if we can reduce the amount of time that it takes to gather the data required for those sorts of things, it really improves the efficacy of those installations, reduces their carbon footprint, improves safety, and overall helps with running that type of installation. And then beyond that, there's all kinds of things for scientific applications and the aquaculture things that I've mentioned.
So really important for preventative maintenance, and then also, yeah, just gathering data in general. I guess you can attach you can gather any kind of data that's out there, can't you?
Yeah, yep. And ultimately, as time goes on and technology development improves, there'll be also not just gathering data, but also carrying out repairs and doing other actions that can be done robotically, so to speak. So all of that is coming to a waterway near you.
Excellent. Hey, thanks a lot, Ben. And we wish you all the very best, and I'm sure we'll be hearing much more from you in the future.
Excellent. Thanks so much for taking the time to talk to me today.